So here's the walkthrough for Lab 1 from week 1. We can go ahead and create another file. Let's put it, I have a folder just for CS105, and I'm going to say lab1.py. Now, I had some issues with people not having a run button. That is because you forgot the .py. But if you go ahead and do that and click on new file, you are ready to go. So here is my lab on the right hand side and my Python on the left. So the first thing that we're going to have to do is print your name to the console. So we read in Python, print the function. The print function is used to print text-based information. Typical function would look like this. Type the above call and click run. So let's go back over on the left and type in print parenthesis quote welcome to my program exclamation point quote close parenthesis, and go ahead and click on the run. On the bottom it's going to go ahead and show that welcome to my program. So perfect. Use the same syntax to print out your name. Don't forget to click run. Okay, so I'm over here on the left. I want to go on the top. I'm going to create a new line and I want to use the same syntax. So what that means is use the print command, do the parenthesis and the quote, and I'm going to type my name. Quote and end parenthesis. And again, don't forget to click the run. Now at the bottom, my output has welcome to my program and my name. I'm going to go ahead and click on save just so that I know my step 1 of part A is complete and I can go ahead and have it there. Print out your city of birth. We could use print to all of our programs output on a single line, but that would not be very easy to read. It's typical to have separate print function calls for each thing we want to print. So copy the function call from step 1 above. Okay, so we're going to say print parenthesis quotes, but don't click run yet. Okay, so after your first line of code, print out your city of birth and now click on run. So we're going to, let's copy that and paste. And then we want to go ahead and say print, and I'm going to put my city of where I was born, Edison, right there. I'm going to go ahead and click run. As you can see down here, each print is putting it on its own separate line, and that's really what I wanted you to see with 1 and 2. Step 3 here, print the results of a mathematical expression. So when you want Python to print something that's not a sequence of characters, you do not use the quotation marks. So let's do a new line and type in print 3 times 4 times 5. Print parenthesis, no quotation marks this time, so 3, and then the times 4 times 5, and then the close parenthesis. Okay, add another line of code to print out the number of seconds in the current month. Have Python do the multiplication using an example as the guide. So we want to print the number of seconds in a month. So the number of seconds, if you look in the hint, is the number of seconds in a minute, which is 60, times the number of minutes in an hour, which is 60, times number of hours in the day, 24, times number of days in the month. So this is the month of June, and so let's go with 30. Okay. Now go ahead and click on run. What this should give us is all of the stuff we printed before, and we're going to print out the value 60, which is 3 times 4 times 5. Okay, so you can see the difference. It's not printing out a string, it's not printing out the numerics, it's printing out the answer to that equation. And that's how we figured out how many seconds are in a month. So that's all there is to step 3. Step 4. I'm going to go ahead and start putting some comments in here so that I know where my steps are. Use the double slash operator for integer division and the percent sign for the integer remainder. Type in the functions below and click run. Okay, so we want to print, and we don't have quotes, so it's going to do a mathematical expression. 44 double slash and a 3. And then we want to do a print 44 percent sign 3. Okay. Now, what this is going to do is it's going to give you the whole number without the remainder, and then the number of the remainder. So 3 goes into 44 11 times with some left over, right? So what is that a leftover going to be? So let's go ahead and click run. So it's going to goes in 14 times. Oh yeah, I can't do math. That's fine. 14 times with 2 left over. That's how that double slash and the percent sign works. So add code to calculate how many full dozens. So that's going to be how many whole numbers. Oh, click back on the top. So if I do hashtag full dozens, and I want to say print 403 eggs, okay, we'll say 12 in a dozen. So how many whole dozens can I get? So I want the whole number of 12 going into 403. The next thing I want to print is eggs remaining. And for that, I'm going to do 403, and I'm going to do the percent sign and the 12. What that's going to do is that's going to tell me how many eggs I have left over. So let's go ahead and click the run. I've got 33 dozen with 7 eggs left over. I'm going to go ahead and click the save, and that's all there is to step 4. Let's go ahead and finish up part A here with a hashtag, step 5. And you don't have to put all these comments, I'm just doing it for you guys. So you can assign a value to a variable. So here are some examples, one that's an integer, one that's a string. So let's type in the code that's there and press run. I'm sorry. So we're going to say age equals 20, job underscore title equals cashier, and we're going to click run. What we're going to notice is nothing's changed because we haven't done any output statements. So everything is exactly like it was before, nothing has changed, which is exactly what the instructions tell you. Now let's go ahead and put those prints. So print age and print job title. Okay, now click run. There's my age 20 and my job title of cashier. Now what step 5 wants us to do is think of 2 other variables and give them meaningful names. Use the equals operator to store the values and then print the values. So let's do 2 additional values. So let's do one that says hourly wage. So underscore wage equals 250. And then let's do another one called location equals quote North Carolina. Okay, I've created 2 different variables. Whatever variables you create, that's up to you. Okay, it doesn't really matter. We want to make them meaningful names so that I can look at that and know exactly what it is. Now let's use our print to print them out. Okay, so we did exactly what we did on lines 19 through 22, but we repeated it for 2 new variable names, and we're going to print those out. Let's go ahead and click run. There we go, 2.5 and North Carolina. I'm going to go ahead and hit click save because we're at the end of step 5. The last thing that we need to do is step 6, and some people had a little confusion with step 6 as well. Step 6. So there is something called Unicode, kind of talked about it in lecture, and there is a link on the course website, and I'll pull that up in just a second on how to find Unicode. So let's go back to our instruction. It says type the below command and type run. So print quote /u to indicate that it's a Unicode 03BB plus Greek small letter lambda. Okay, so the /u is what it's going to tell the compiler that I'm going to have a Unicode numeric that's coming after it. Let's go ahead and click run and let's see what this looks like. So what it actually does is it prints out a funky character, a Unicode character. Okay, so now what step 6 is saying is print out 6 different Unicode values that you haven't seen before. So let me take you back over to the course website and let me show you where that table is. Okay, I've come back to our course web page, sorry. And if you come down, if you go into the week 1, if you scroll down into the resources, one of the links actually says Unicode table. If you go ahead and click on that Unicode table, what it's going to do is it's going to give you all the different examples of Unicode characters that are available to you. So pick one that I'm going to go ahead and just select, let's look at Greek letters. So what I can see from here, I'm going to zoom in quite a bit on some of these Greek letter indicators. What I can see is each one of these characters has a 4-digit code based underneath it. So whatever character I want to use, I need that 4-digit code. So let's take the lowercase pi here. It's a 03C0. So if I go back into my code, and I say print, I can print with a /u the 03C0 with the quote and the close parenthesis. Now if I click on run, what it's going to do, it's going to put that lowercase pi out there. That's how you're going to find 6 other Unicode values. So make sure that you have, it says to use the character and then the name of it. So in order for me to add the name, I do just like it's above and add an add and say Greek pi. Okay. So really, to finish this off, it would just be adding 6 of those additional characters. Hopefully this was helpful for you. Okay, let's go ahead on to part B of Lab 1. I got a new file. I saved it as Lab 1B PY. So let's go ahead into number 1. Let's dive into step number 2 because step number 1 just has you create the new file. So step number 2 says print using the comma to separate inputs. So the print function takes inputs, and what we can do is we can give it multiple inputs. If we separate them by a comma, if we do that, when it prints to the console, it's actually going to be separated by a single space. So let's go ahead and type and run print 21, comma, 4 times 32, comma, and the word hello. Let's click on run and see what's going to happen on that in our console. So it's going to print the number 21. It's going to print the actual resultant of 4 times 32, and it's going to print the word hello. Now we can print out different types of values. So step 3. So we can actually print out the binary, the hexadecimal of a number. It's whatever you want. So what we're going to do, let's find the bin function and the hex function, which are going to return the binary and hexadecimal versions. Let's assign a variable. We're just going to call it x to the numeric number 31. Let's print out now x, a space, the binary of x, a space, and the hexadecimal of x. Let's go ahead and click run. So what it's going to give you, it's going to give you 31. This is what 31 in binary is with the 0b in front of it, and in hex with the 0x in front of it, 1f. So that's how you can actually have output in either base 10 binary or in hex. Let's go up to step number 4. Step number 4 says assigning a binary or hex value to a variable. So let's type in the code that's there. So y equals 0b1011, and we're going to say z equals 0xa3. Now, if we say print x or yz, let's see what happens. Click on run, and it actually prints the base 10 of that hexadecimal number with the x in it, or that binary number with the b in it. Let's go back up to the code. Let's go on to step 5. So here it's telling us we can add numbers in any representation. So now if I say w equals x plus y plus z, okay, and then I say print the sum is, and make it a string. Let's take a quick look at what it's going to do before I hit the run button. So it's going to, in the variable w, it's going to take the value for x, which up here on line 5 is 31. It's going to add to it y, which is on line 9, the binary of 1011. And then finally it's going to add to it the hexadecimal of z, which is on line 10, A3. So what it should do is it should be adding up 163 plus 11 plus 31. Let's take a quick look. The sum of all those numbers is 205. So you can see it doesn't matter if it's in binary or hex or in base 10, it just goes ahead and adds up those numbers into base 10. That is all that was required of part B for the lab. Just go ahead and save this file. Part C of lab 1, we're going to create a new file. Now something's going to happen when I do this file. I'm going to go ahead and give it a name. Again, I apologize, but I have my own lab1c.py and create new file. Let's go ahead and type in the below command for step 2 and say print. We're going to say the @ sign, which is above the number 2, plus a period plus a blank. And let's click run. Now, one thing that it's telling me is that my console limit has reached. You don't have to pay for extra. If you come up here and go to consoles, you can actually X out of the consoles running because you're only allowed 2. You can go back to your file, open it back up, click the run, and you should have no problem running that file again. If I wasn't in any of your files, I cleared out your consoles, so don't even worry about that. Okay, so now we can do something called replicate. So we want to replicate with the multiplication sign or the star. So we want to, let's type in that second command there. So let's say print, oh, let me add the step number. Oh, it's still on step 2, sorry. Print the @ sign. Okay, now what we want to do, actually we're going to do 3 @ signs, sorry. Now what we want to do is do the star to multiply it. So we want to take 3 of them and do it 3 times. Okay, plus ... If we go ahead and click run, what it should do is print 3 @ 3 times, which is all of that, and then 3 dots. So let's take a look. There we go. There's all my 9 ats and my 3 dots. Now, the last thing that step 2 is asking you to do is write a single print statement that's going to print out all of these characters, okay? Let's look at what is repeated. So let's do a print. Okay, we've got a $sign. I mean an ampersand, sorry. An ampersand 4 times. Okay, and you've got 2 dots. There are a ton of different ways that you can do this. This was one of the ones I accepted. Okay, and that is being repeated 1, 2, 3, 4, 5 times. So I want to do times 5. Plus, I want some plus signs there. So how many do I want? I want a plus sign times, that's not a plus sign. Yeah, it is. Plus times, sorry. And we've got 1, 2, 3, 4, 5 times 5. I'm going to go ahead and click on run, and what it should give me as my output is all of those concatenated together. You can go additional into it and do a $, or the ampersand times 4 and the dot times 2. There are so many different ways to do it, but this is just one of them. The last thing that you were supposed to do is to take this grid and fill in some of the squares and make a design. You can make your initials, a picture, or an emoji. And the whole point of that was to use the prints with some of their print statements and your concatenations in order to make a picture. That was all that was required for Lab 1. I hope this answered some questions that you had, and if not, just reach out to me.